Hello friends, in the present video, we will see how to find the bearing capacity of a pipe. In clays. So I'll simply write it down as file capacity in clays. So if I recall, what is the capacity of a pile can be written as QUP, that will be equal to end bearing capacity plus frictional capacity. What is the end bearing capacity? End bearing resistance into end bearing area plus screen friction resistance between the pile and the soil into surface area. So what are the unknowns in the present case? You should know what is the value of end bearing capacity, and also you should evaluate the what is the screen friction resistance, right? Now let us recall bearing capacity of a pile in shallow foundation. What is the bearing capacity? That will be equal to QU, isn't it? That will be equal to CNC plus gamma D NQ plus of into B into gamma into N gamma, isn't it? If you recall the equation. Now, which type of soil we are talking about? We are talking about for clays. If you are talking about for clays, what about the N gamma value? N gamma value will be equal to 0 and NQ value will be equal to 1. Then what about the N bearing capacity? So this QU that will represent as an N bearing capacity. That can be written as CNC plus gamma D, isn't it? But it is found that your C into NC is coming very larger in comparison with the what about the magnitude gamma D. So that's why your end bearing resistance can be considered as only C into NC. So if it is a clay, what is the end bearing resistance? That is nothing but a C into NC. So what is meant by C here? C can be written as undrained shear strength of a clay. Undrained shear strength of clay. At where this is what important. At where as you're finding at the end, that means at the end of the pile, that means at the tip of the soil. That means at the tip of the pile. So in sometimes you may have the uniform cohesion, and sometimes you may have the different cohesion values, like means different strata. So C is nothing but at the tip of the file, your undrained shear strength. So normally in general, NC will be varies from 6 to 10. So, but it is recommended that it's better if you take NC as equal to 9. If NC is given, directly consider that value. If NC is not given, then your end bearing capacity is nothing but a 9 into C. So this is what about the end bearing capacity. Now coming about the frictional resistance. What about the frictional resistance? QS. So that can be written as in general K into sigma effective vertical stress into tan delta. So this is can be applied for any type of the soil. So if you are talking about the clays, what about the delta value? That will be considered as a 0. So that's why this becomes the undefined. So that's why in clays, QS will be considered as a alpha into Cu bar. Alpha is nothing but a friction factor between friction factor, or else we can also call it as a adhesion factor. Adhesion factor between soil and pile. And Cu bar is nothing but a average shear strength of a soil. Average cohesion. Let us say simply I will let it down as an average cohesion. So this is what about the friction resistance for a clays. Now, tell me, suppose if it is a friction pile. Now tell me, what is the capacity of a pile? So all the equations we are talking about the clays only. If it is a friction pile in clay, what is the ultimate capacity of a pile? That will be nothing but a QS. That will be equal to QS into AS. What is meant by QS? Adhesion factor into average cohesion into AS. Similarly, if it is an end-bearing pile, whatever the ultimate capacity of a pile, that will be equal to QB. That will be equal to QB into AB. Whatever the QB value, that can be written as C into NC into NP. If NC value is given, then you can substitute it. Otherwise, you have to consider it as a 9. 9C into, sorry, this is AB, right? So all this is for clay. Suppose if it is friction and end-bearing pile. So whatever the ultimate capacity of a pile, that can be written as summation of the QS plus summation of the QB. Now, by using these relations, we can find out the ultimate capacity of a pile in clays. In the next video, we will solve some problems based on the pile capacity in clays. Thank you.